So now let us talk about dimension. Dimension are the powers to which the fundamental units are raised in order to express the derived unit of a quantity. Not understood? Let us make it more clear. Suppose area, meter square. So length 2 times we are multiplying. So what is the dimension of length over here is 2. So dimension is giving the power, okay, here 2 times length is multiplied so fundamental unit is multiplied 2 times so that we get a derived unit. So dimensions are the powers to which the fundamental units are raised. Fundamental unit are raised to 2 times in order to express the derived unit. So in order to express the derived unit, this derived unit is expressed by this fundamental unit. How many times raised? 2 times. So dimension is 2. Volume, length is multiplied 3 times, so here dimension is 3. Density, density is a derived unit. Mass by volume, mass is m, volume is length which is multiplied 3 times, so L, m by L to the power 3. Now since it is in down, when I will put it up, this 3 will get a power of minus 3. Is it clear? So what is happening? Derived unit is expressed in terms of 2 fundamental units which are raised to some power. So m's power is how much? Nothing is there, means 1. M power is 1. L power is how much? Minus 3. So if I ask what is the dimension of mass in density, it is 1. What is the dimension of length in density? It is minus 3. What is the dimension of time in density? Time is not there. So anything to the power 0 is 1. So t power 0 can I write? So dimension of time is 0 in density. Is it clear? Then let us talk about velocity. Velocity is equals to distance upon time. So distance is L, time is t. This t, if I take it up, t to the power minus 1. So I can also write it like this. m0, m is not there, so n to the power 0. So it will become 1. So even if we write it, there is no problem. Even if we don't write it, there is no problem. But in some books it is given like this. In the other books it is given like this. So don't get confused. Both are the same things. So m to the power 0, L1 and t to the power minus 1. So what is the dimension of mass in velocity? It is 0. What is the dimension of length? It is 1. What is the dimension of time? It is minus 1. Then acceleration, velocity upon time. Velocity just now we found out, Lt minus 1. Time, t I will write it down. This time if I will take it up, so t to the power minus 1, t to the power minus 1, t to the power minus 1. It will become t to the power minus 2. Or we can also write it as m0, L1, t minus 2. Both are same thing. So this is the dimension of acceleration. Let us come to force. Force is equals to mass into acceleration. Mass is m, acceleration is Lt minus 2, just now we found. So add it, means so multiply it together. So m L t minus 2. This is very important. We want to just keep it in mind always. As soon as I say force, you must remember that it is ml t minus 2. ml t minus 2. Always remember, ml t minus 2 is the dimensional formula of force. So either you write mass into acceleration, it is the formula. Okay, it is the formula which is given. But the dimensional formula, if somebody will ask, we will write this ml t minus 2. Okay. Then momentum. Momentum is mass into velocity. So mass is m, velocity is Lt minus 1. Just now we found that out, ml Lt minus 1. So mass is m, so mlt minus 1. This is for momentum. Work. Work is equals to force into displacement. Force just now we found out, mlt minus 2. So mlt minus 2. Displacement is length, so L. So m L square t minus 2. Now this is the next important formula that we will remember. Some of the formula, students, we have to keep it in mind always. Okay, like force, ml t minus 2. Then work, ml square t minus 2. These two things you always keep it in mind. Now work is equals to force into displacement. Now if I talk about energy, why work is important? Because work is it is the energy is the work done is the due to energy. So both are same thing. We have studied this in class 9th also. Work and energy are same thing. So here we'll see that energy's dimension is also work's dimension. So ml t minus 2. So energy is ml square t minus 2. It is very important. Okay. So if we want to find kinetic energy, half mv square. Half, so it is a numeric part. So it is not having any unit. M mass, v square, lt minus 1 square. So L square also t minus 2. So m L square minus t minus 2. So energy we found out here in this case m L square t minus 2. In kinetic energy also we are finding this. If we try to find potential energy also, mass m, g is the gravitation, acceleration due to gravitation, that is acceleration. Acceleration is lt minus 2. We have find it out, velocity upon time. And height is the length L. So we will see ml square t minus 2 over here also. Impulse, force into time, electric charge. In this way you try to find it out, find all the dimension formula of the physical quantity.